Good morning, students. Today we are going to discuss reinforcement detailing of a cantilever slab. As in yesterday's numerical, we went through this design. We have completed this design of a cantilever slab. So now let's discuss why this reinforcement is designed in this way. Means the bars are provided in the upside, not in the downside as usually being provided. So let's begin with our discussion. Firstly, let us understand the shear force and bending moment diagram of a cantilever beam. As you already have studied that a cantilever beam is a beam which has a one end fixed and other end free. So we'll have its fixed bending moment as WL square by 2. The maximum amount of bending moment will be at the point B and minimum amount will be at point A, that is 0. When we are talking about the shear force diagram will look like this. Here also we have the maximum shear force as WL, which will be acting at the fixed end, and the minimum shear force will be 0, which will be acting at the free end. So we have been clear from here that in a cantilever slab we'll be having maximum shear force and maximum bending moment at the fixed support. So like in all the slabs, like in one-way slab and two-way slab, we were providing a continuous depth, uniform depth throughout the section. But here from the bending moment diagram, it is obviously visible that the value of bending moment is lesser at point A and value of bending moment is greater at point B. So we need not to provide the same depth as required at point B to the point A. Means we can differ the depth at point A as well as point B, so that we can reduce the amount of material being used, amount of concrete being used, isn't it? So in order to make our section economical, or in order to reduce the cost of construction, we may reduce the amount of concrete being used at point A as compared to the point B. So first of all, what we do, we reduce the cross-sectional element we do not provide an overall depth like same as in one-way and two-way slabs, but we provide a trapezoidal shape of depth, means in this way, that is a greater depth at point B, that is at fixed end, and a smaller depth at point A. So this would be clear here. As you can see, a greater depth, that is 200 mm, and 115 mm smaller depth at this end. Now coming further, when we are talking about the cross sectional element of a cantilever slab, it will look like this. Let me draw. Here we have a cantilever slab. So when we are talking about its cross section, we can see its cross section would be a rectangle one, like this. When load is coming on it, load as UDL will be coming, this UDL will cause this to deflect. How? This will deflect in this manner, causing compression at the bottom and tension at the top. Here we can see the tension will occur at top and compression at bottom. That means, once again let me tell you, see, this cantilever beam will be bending in this way. The topmost fiber will undergo tension and the bottom fiber will go compression. Unlike in a simply supported beam, what happens here? Here the deflection goes like this and the upper portion goes into compression and lower portion goes into tension, but here the case is different. The upper portion went into tension and lower portion comes into compression. So as we know, the steel reinforcement are provided in the tensile zone. So where will be the steel reinforcement provided? Either in upper zone ऑफ द न्यूट्रल एक्सिस के ऊपर प्रोवाइड करेंगे स्टील्स को या न्यूट्रल एक्सिस के नीचे. yes, obviously we'll be providing the steels in upper side from the neutral axis. So we have done this. Here you can see in this diagram that the reinforcement are provided in the upper side. The reinforcement are provided in the upper side and not in the lower side. So the main bars has been provided along the upper area or the upper from the neutral axis. When we are talking about its neutral axis, we have provided the bars in the tensile zone, that is in the upper area from the neutral axis. So we have provided the bars in the upside. Okay, now this is the wall from where the cantilever has been or the projection has been done. Means इस wall के आगे ये overhanging part है, cantilever part. So the thickness of wall here is 230 mm. This is our development length. Bars has been anchored here. In this, the main bars as well as the distribution bars both were provided 8 mm bars at the rate 130 mm center to center. As you can see, this is the main bar. This straight line is showing the main bar and these dots are showing the distribution bars. So I hope this reinforcement detail has been clearly understood by you all. You all must have been aware now why the reinforcements are being provided in the upsides and the depth of this cantilever slab is varying. Why? You must have understood from this video lecture easily. One more thing I would like to tell, you must also have seen chhajja or sunsets. Chhajjas being provided over the windows, you must have seen to protect from the sunsets. So the chhajjas are also somewhat similar to this cantilever slab and they are also designed in the same manner as we design this cantilever slab. Means छज्जा भी एक तरीके से देखा जाए तो क्या है, वॉल, देन वॉल से कुछ प्रोजेक्टेड पार्ट. तो छज्जा को भी सेम इसी तरीके से जैसे हम कैंटिलीवर स्लैब को डिज़ाइन करते हैं, इन द सेम मैनर वी डिज़ाइन छज्जाज above our door lintels and above the windows. Chhajjas are also known as sunsets. So we also design sunsets or chhajjas in the same manner as we design these cantilever slabs. So you can also go through these designs and you can also learn the things how chhajjas can be designed using the same method as described in the previous video of designing of cantilever slab. You must go through the design of cantilever slab as in previous lecture. I will give you the link in the description of this video also, so that you can go through the design of this slab in detail. I have completed all the detailing and designing in the previous lecture. You can go through that video. Okay, thank you students. Hope you all have understood all the things clearly. Thank you. Do like, subscribe and share.